Okay, so let's try number 38 in 20.3, which says we have a scalar function f with continuous second order partials, and we have a vector field f with continuous second order partials. And then they're asking us which of these things are identically zero. So they ask us first about the curl of the gradient of f. So first off, what category of object should the output here be?
It should be a vector.
Should be a vector, right? Because you got this out of a curl. So this should be Nabla crossed with, what's the gradient of f? How do you get that?
Nabla to the scalar f.
Nabla scalar f, right?
Which should be zero.
Which in the end is a cross product of, or at least I'm thinking of it as a cross product of a vector and a scalar multiple of itself. So you should get out of this zero vector. Good with me on that? Okay. How about f crossed with the curl of f? That's weird.
So say not zero.
Okay, so that'd be f crossed with Nabla crossed with f, right?
Nabla cross with f is perpendicular to both Nabla and f.
Yeah.
Perpendicular.
So,
it would be like a
okay.
maximum of a.
You guys see this? So the result of Nabla crossed with f, right, should be a vector that's perpendicular to
Nabla and f.
both Nabla and f. You guys see this? And so when you cross product that with f,
You get Nabla.
kinda, yeah. You guys see that?
Oh.
Like if you take three vectors, so what if these were actually vectors? Like what if I just took v crossed with w crossed with v? Okay, see that? Like the result of this is going to be the vector that's perpendicular to both v and w with some properties, right? When I cross that with v, I'm going to get probably w or maybe minus w depending on how the handing works out. You guys see that? Or at least some scalar multiple of w maybe.
So it'd be
not
Nabla plus or
zero.
minus Nabla.
So I think this one's not identically zero. Let's see, is there another way to look at that?
Would that be a vector? Or would
It's
that
a
be
vector.
Scale.
Vector,
Yeah.
not scalar, but I don't think.
Yeah, this should be a vector. I'm a little bit skeptical of my reasoning on that one, but okay. How about this thing? Gradient of the divergence of f.
Nabla.
So if I was thinking about this in Nabla land, right? This is Nabla
Dot.
Scalar multiple.
scalar multiplied by
Or, yeah.
Nabla
Dotted with
dotted with f. You guys see this?
Oh.
So
Huh.
it's kind of like Nabla squared times something.
Okay, so I think because we could say that f has consecutive second partials, wouldn't this be similar to the second partial? So
I don't know, let's freaking try to calculate one. Right? Like, I'm not sure. Let's calculate. We can calculate. So the divergence of a vector field f, right? Let's see, so I should be taking the gradient, right? Of, what's the divergence of a vector field f?
Scale.
How do you take the divergence of a vector field?
X partial to x, y partial.
Yeah, f partial x, y partial with respect to y, and the z partial with respect to z, right? So you get the partial of fx with respect to x,
partial of fy with respect to y.
But what are you doing with these?
You're then
Adding them?
you're
So that's why I said scalar.
Right? And then you want to, that's a scalar function, right? You guys see that? And you want to take the gradient of that thing. So when you take the gradient of that thing, what do you take the gradient of?
it's
The gradient's a vector, right?
So it turns back into a vector.
it's like partial of f with respect to f.
So I need to take all this crap, take the partial with respect to x of it. You guys see that? Is that obviously going to be 0?
The y and z don't make it through, so I think that f of x would.
Oh no, don't assume that. That's crazy talk.
Oh,
You're taking the partial with respect to x of all of this stuff, right?
okay.
The other stuff might be carried to the constant.
Yeah, so the partial of fy with respect to y, right, could certainly still have x's in it. You guys see that? It doesn't have to, but it certainly could, right? So I think this is, I mean, it's a mess,
Well, I don't think it's 0.
but it's definitely not necessarily 0. Definitely not necessarily. It could be 0, right?
But not always.
Not necessarily.
So what the book asks is, are these necessarily 0?
Oh.
Not which are sometimes 0, not which could be 0, but which are always 0.
Okay.
Is that what it means by identically?
Yeah.
Okay.
Yeah, what they're trying to protect from is the idea of 0 sometimes versus all 0 all the time. You guys see that? Okay, so I think that's that one. How about the divergence of the curl of f? You guys remember this one?
0
Cross.
This is the thing in the divergence test, right? You guys remember that? Or alternatively, this is Nabla dotted with Nabla crossed with f, right?
Yeah, that's just perpendicular.
Intuitively, that should be, this thing is perpendicular to both Nabla and f, and when you dot product with Nabla,
It's something perpendicular dotted with each other.
you're dotting something that's perpendicular, right? So you get there, huh?
Yeah, this one's just a scalar.
And that one's a scalar because it's a divergence, right? Okay, how about this other thing where you do the divergence of a gradient of f?
So it's pretty much the first one. Let's see.
So that should be Nabla dotted with Nabla scalar multiplied by f, right?
That's like the same as C one. That looks or actually.
It
Looks similar. But in this one, the scalar multiplication's happening first, and then the dot product. And in this one, we were dot producting and then doing scalar multiplication.
Because we're turning to a scalar.
Do you guys see how they took different categories of thing? Right, like when I did gradient of divergence, this was a vector field. That's taking a scalar function, right, to start with. You guys see that? Do you expect this one to be 0? Should we calculate this one?
Yeah, we can't assume, I don't think.
Okay, so we could try to calculate a thing. This one should actually be easy. I want to take my idea of a gradient and dot product that with fx, fy, fz, right?
Okay.
So what are you going to get out of this thing?
The,
This one's actually kind of cool.
It should just be one.
the gradient of that.
How much does it?
Yeah, you get the sum of the identical second partials, right? So you get fxx plus fyy plus fzz,
So
which is not necessarily 0, right? Again, it certainly could be 0.
Yeah.
but it's set up there, continuous second part.
Well, the continuous could end up being.
Yeah.
So the continuous second partials basically just means, yeah, you can calculate these objects at all, right? Like, if I didn't have the continuous second order partials on these,
Not say any of this is right.
yeah, some of these might not even make sense.
Yeah.
Right? And so then they wouldn't be identically 0 because they wouldn't even make sense to be equal to
Or
0.
basically, you could just say they're not identically 0 because some of them don't even have a second partial.
Yeah, exactly. Some of these things might not even exist. I'm worried about B. So let's check our intuition on B.
But E is not scalar 0,
E is not identically 0.
but of scalar form, not vector form.
Yeah, it's a scalar. Okay, I want to check B because B scares me.
What did we do before?
I said something about B, but I said it was... Right, remember when we were doing B, we said, you've got a vector, right?
Mhm.
So you take two vectors, you cross them, you get another vector that's perpendicular to both of those. And then you cross it with one of the ones you started with.
Uh-huh.
So you're probably going to get plus or minus at least whichever vector wasn't in there twice. That's like, I'm thinking this is going to give me plus or minus Nabla, right?
Yeah.
But Nabla's not a freaking vector. It's just the idea of a vector, right?
Oh.
Like, it's the idea of taking a gradient. So I'm worried about that one because I said something, and then I got to thinking about it as I was doing the rest, and I'm a little bit skeptical. So let's calculate that one, right? We can do that. We have tools. So let's take a vector field F, which I'm going to call
The XYZ, because it's already XYZ.
PQR, because I'm trying to confuse the shit out of you today. Sorry. And then I need the curl, right?
RQP, or?
Okay. So first things first, I better figure out the curl of F, right?
Which is use the RQP this time.
So R, Q, P, R, Q, P.
Yeah, just subtractions and partials everywhere. Like.
Yeah, throw in symbols. Oops, not that symbol. That's the wrong symbol. Commas, symbol, symbol, commas, thing. Okay.
And then it's
And then they're
Y, Z,
partial with respect to
Y,
Q.
Y,
Z,
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 X,
X,
X, Y.
Y. God, I almost have the curl formula actually memorized now.
Y is easy.
Okay. And I want to take F and cross it with that, right? Okay, so
Okay.
for this, I'm going to need a chair.
Yeah.
Okay, so I want P, Q, R, right?
And then
I,
J.
J, K.
No.
Determinant. Right, but all I want is the first one. I just want to know, is this necessarily 0 all the time, right?
Okay.
So my first thing first, right,
Is partial of, is it
is just going to be Q times
partial of Q over X?
so
and
Q with
minus-
respect to X minus partial P with respect to Y
minus
minus
R
times
partial of P
partial of P with respect to Z
minus partial of R with respect to X. And that's the first one. I don't think there's really much we could say.
You guys with me on that? So my claim is that this thing is not always identically 0, right?
Mm-hmm.
You guys see that? So I need to produce a vector field where this component's not 0. So we need to come up with PQ and R so that this chunk's not 0. You guys with me on that? So I'm going to go with the easy choices. I'm going to make R 0.
If we, 0, X squared, 0.
You guys see that?
something like that.
So I'm going to make R 0. That's going to make this piece 0. Fine. I'm doing that so I only have to fill with one of the pieces. And then all I need is for this thing to give me not 0, right?
So Q Q needs to be at least have an x component.
So here's my, put a 0 in for R.
What if you do like x, y, f, y?
I would just say 0, x squared 0, personally.
Just a 0.
Okay, that's a good plan, right? Let's try 0, x squared 0. So I got partial p is 0. So that piece is 0. Partial of p is 0 because p is 0, right? And then on the other thing, I got x squared times,
Partial of x squared, which is 2x.
which is not 0.
Yeah.
Cool. That's the only one I was worried about. The other ones, the reasoning's pretty solid. You guys cool with that? That's very cool.